All right, thanks for watching. And here's a linear algebra topic that is crucial for what's to come, namely orthogonality. So here, let u, v, w be vectors. What's your vector, Victor? And by the way, when I write underline, I really mean boldface. And in particular, we say u and v are orthogonal or perpendicular if the dot product is 0. So in other words, a really 1 second way of checking for perpendicularity. U and v are orthogonal or perpendicular if u dotted with v equals 0. Now, in particular, what does it mean for a whole set to be orthogonal? It means that each vector is orthogonal to everything else. So in other words, for 3 vectors, u, v, w is orthogonal in this case if u is orthogonal to v. So in other words, if u dotted with v is 0, u orthogonal to w, so u dotted with w is 0, and finally v dotted with w is 0. In other words, every vector is perpendicular to every other one. By the way, why didn't we do v dotted with u? Because it's the same as u dotted with v. And why didn't we do u dotted with itself? Because we want every other vector, so not to itself. In fact, u dotted with u is itself non-negative. Okay, and here is why orthogonality is important, because it allows us to find the coefficients in a linear combination very easily. Here's what I mean by that. So, ultra important fact, and I cannot emphasize how important it is. So suppose, again, u, v, w is orthogonal. And moreover, u, v, and w is non-zero. So, and u, v, w is not the 0 vector. And moreover, some vector x is a linear combination of u, v, and w. And x is a times u plus b times v plus c times w for some a, b, and c. Or in linear algebra terms, suppose x is in the span of u, v, and w. Then, if you know a little bit of linear algebra, you may notice it's a real pain to find a, b, and c. Because you would have to row reduce, solve a crazy system of equations. But not so with orthogonality, because if u, v, and w are perpendicular, then it's actually very easy to find a, b, and c. More precisely, we have super explicit formulas for the coefficients, because a is just x dotted with u over u dotted with u, and b is x dotted with v over v dotted with v, and finally c is x dotted with w over w dotted with w. So once again, I cannot emphasize how important this is. If a vector x is a linear combo of orthogonal vectors, then we can actually find the coefficients explicitly. We have a super elegant formula for this, which is what will make Fourier series work, which is our next topic. And I will prove this, but before that, I want to give you an analogy. So suppose I am x, and those are the vectors u, v, and w. So this is u, this is v, this is w. Don't ask me why I have all those plush toys. But suppose I am very happy and I hug everyone. So what I do is I am x and I hug you. So x started with u, and then u is so happy it hugs itself. U dotted with u. So that's what I call the hugging analogy. X hugs u, and then u hugs itself. And then same for y. X hugs v, and then v hugs itself. And last but not least, same with for w. So x hugs w, and then w hugs itself. So remember this because we will apply it in a more complicated situation in the next video. Last but not least, why is this true? Let's prove it. So why? So suppose, once again, x is au plus bv plus cw. And let's take x and hug it with u and see what we get. So then x dotted with u. Well, by definition, x is au plus bv plus cw. So that is au plus bv plus cw dotted with u. Now, let's expand this out. So this is a times u dotted with u plus b v dotted with u plus c w dotted with u. However, what do you know about the set u v w? It is perpendicular. It's orthogonal, meaning that each vector is perpendicular to the other ones. So in particular, v is perpendicular to u, so this becomes 0, and w is perpendicular to u, so this also becomes 0. So once again, this is since the set is orthogonal. So very important. It's false in general. It's orthogonal. And once again, u is not perpendicular to itself because u is non-zero. And so after the fog has settled, or the dust has settled, we end up just getting a times u dotted with u. And so reading this from right to left, so Persian style, we have a u dotted with u equals x dotted with u. And then last but not least, we get a is x dotted with u over u dotted with u. So you see, we have the formula for a, and of course, similarly for b and c, if you hug x with v and hug x with w. So similar for b and c. And in the next video, we will find a really cool application of this where we write f, a function f, in terms of sine waves. So make sure to check it out in the playlist. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.